Okay, welcome to HPC Now. Thanks for joining. We've got a great session for you today. It's a short one, so just hang on. We got a couple of things to talk about here. And to do that, I have Dr. Albert Reuther from MIT Lincoln Lab here to talk about a couple of different areas. One is going to be about workloads and the importance of workloads. The other one is going to be about reference architectures. So what I'm going to do first is have Albert introduce himself, talk about MIT Lincoln Lab and what they do, and then what he does at MIT Lincoln Lab. So Albert, why don't you take it away?
Gladly, Tony. I'm so glad to join you. MIT Lincoln Laboratory is part of MIT, the university up in Boston, Cambridge, Massachusetts. And Lincoln Lab in particular is a federally funded research and development center that does prototyping for the Department of Defense and other government agencies in service to national security. And so in doing that, we have lots of data and we crunch lots of data. And so I'm one of the founders and builders of the Lincoln Laboratory Supercomputing Center. I've been doing this for about 20 years, starting off with a small 4-node cluster, and now we have about 2,000 nodes as part of our flagship system. I've also built a number of embedded systems, about 70 of them, that have gone into submarines, bread trucks, on ships, and even in the bellies of some aircraft to do signal processing and other data processing for national security type of applications.
Wow, that's fantastic. Great background. So now, Albert, one of the topics we want to talk about today is the importance of workloads and how the workload drives the architecture. The architecture doesn't drive the workload. Do you want to spend a few minutes talking about that?
Oh, gladly. Yeah, the workload is the most important thing, especially when you're building a cluster for a certain type of application. Some like our flagship system is very general. And so we do have requirements for that flagship system as to what it is intended to, it's built for. But other applications are much more specific, like the bread truck system or the aircraft belly of the aircraft system, where so like an example of that, one of those aircraft systems, it was all about signal processing. And so it was getting data from a set of sensors. It had to move that data through the storage to be stored and recorded for later analysis, but then also process some of that data and push out products to the crew on the aircraft as it was flying. You're going to develop a different system from all the way from the networks to the storage to the processors and servers on board. It's going to be very different for that application as opposed to an application, for instance, where I'm training neural networks to do classification of the images that are coming off of that aircraft. And sometimes then when you have multiple applications on it, you're going to try and find something that is the best of both worlds, best of a signal processing system as well as a machine learning processing system that is able to satisfy the requirements of both of those applications.
So, so the workload is the key part that defines the architecture. In other
Absolutely.
words, right.
Absolutely.
So, when you go to develop an HPC system and configure that and determine the architecture, the first thing you do is what am I going to run on it, right? And that
That's
dictates
right.
exactly the components of the system.
That's right. And those requirements can come from both a back of the envelope calculation of I'm going to have this much data coming through.
Back of the envelope.
Back of the envelope, absolutely.
Yeah,
we know how much data is going to come through. We know how much throughput we're going to need, both in terms of data as well as in computations. And then it may even be some benchmarking or some example applications that have been run on some sort of representative hardware where you get a sense of where the pain points are in doing that data movement and the data processing that then inform the purchase decision and often inform it in very significant ways.
Right. So from the workload, you develop a set of requirements for the system, and that dictates how you architect it.
Absolutely.
Yeah.
And
okay.
We will bound it then sometimes with cost, where we're trying to find, say, like the sweet spot of the best processor that we can get and the number of nodes that we can get for a certain dollar amount. But that often comes in, that actually always comes in a little bit later. It's setting up the technical requirements first.
Right. Okay, that's great. Thank you very much for that. Let's move on to the second topic, reference systems. All right. So we have, at Dell, we have a lot of reference systems, but everybody has reference systems, right?
Absolutely.
And they go by all different names, right? But, you know, there's a common perception that the reference system is the final system I deal with, right? And a lot of times I like to look at that as a car. When you get a car,
Yeah,
right? You go in the ad, you see an ad on the TV, and you go, wow, I really like that car, I want to get that. But what you end up getting is not that car because it doesn't quite fit what you need. Do you want to
that's
comment
right.
a little bit? You want to comment a little bit about that?
It's an excellent analogy, Tony. The reference system, from my perspective, the reference system has several purposes. First of all, it shows that your company has gone through the exercise and your team has gone through the exercise
Right.
of understanding what the problem requirements are for a certain type of processing at a large scale. Also, you've gone through the scalability studies to
Right.
understand where are the
Right.
pain points in that reference system and how does the system address what the applications will need to do. Um, the other part of it is it can be a starting point, just like the car analogy, where I see that ad and I will say, ooh, I like that car. There's some things that I'd change on it, but that's a good start for what I'm going to
Right.
go into the
Right.
dealer to talk about what I'd like to get. And that becomes the beginning of the negotiation of,
Right.
do
Right.
I need more memory? Do I need this type of Ethernet network instead of InfiniBand network? Should I get more cores on each of the servers? And how many servers so it becomes a starting point if there is no starting point. Um, and it is very valuable, but the likelihood of us, even in all 70 of those systems, to buy something that closely resembles the reference architecture is kind of unlikely, because
Yeah.
we will meander from that, very purposefully meander from that to a system that really is designed to match the requirements of the application set.
Right. Of the workload that's going to run on it, right?
Absolutely, of the workload. Because in the end, when the teams that are using the cluster are satisfied with running those workloads, and it's been derived from the workloads, they're a very happy customer.
Yeah.
If
Yeah.
I try to shove something down their neck to say no, this will work, without the backing of the numbers and the requirements and satisfaction of the requirements, it just does
Yeah.
not end
Right.
up well.
Right. All right. Well, that's great. All right, Albert. Listen, that was great. That was fantastic
Super.
description. Thank you very much. I appreciate it. And we always like having you on HPC Now. So you're
I
you're you're a fantastic interviewer. So thank
thank
you
you very
very
much.
much.
Glad to join
Okay.
you.
All right. Thanks a lot,
All
Albert.
right, Tony, that
Have
that was
have fun
easy.
shoveling all that snow.
Hey, the snow thrower is fantastic in these jobs.
Thanks for watching HPC Now. I hope you got something out of it. With regard to workloads, how workloads drive the architecture. So it's very important to talk to your data-centric workload specialist who understands the workloads and how they translate into the architecture. The other thing is, with regard to reference architectures, it's like buying a car. You see the ad on the TV, and you know that hey, that's a beautiful car. But what you end up is negotiating a little bit with the dealer, and you end up with a car that's similar to the one that you saw, but you end up getting something that's a little bit different, tailored more exactly to your needs. And that's what we do. So again, thanks very much for watching, and be safe. I'll talk to you soon.